Inside the atom, the theory that changed matter forever. The invisible revolution. Everything around you appears solid. Yet solidity is an illusion. At the deepest level, matter is almost entirely empty space, governed by rules that defy intuition. Understanding this required one of the most radical transformations in scientific history. This is the story of how modern physics rewrote our understanding of the atom, and with it, reality itself. Part 1. The classical atom. For centuries, atoms were imagined as indivisible building blocks. In the early 19th century, John Dalton proposed that all matter was composed of tiny, solid particles called atoms, each unique to an element. This model explained chemical reactions elegantly. Atoms combined, separated, and rearranged but remained intact. Matter appeared stable, predictable, and mechanical. The atom was assumed to be the smallest unit of reality. That assumption would not survive the next century. Part 2. The atom breaks open. At the turn of the 20th century, experiments began revealing unexpected behavior. In 1897, J. Thomson discovered the electron, proving atoms were divisible. Matter was no longer fundamental, it had internal structure. Soon after, Ernest Rutherford conducted experiments that shocked the scientific world. Most particles passed straight through thin metal foil. A few rebounded violently. The atom, it turned out, was mostly empty space with a dense nucleus at its center. Solid matter was no longer solid. Part 3. A planetary illusion. To explain atomic stability, Niels Bohr proposed a planetary model. Electrons orbited the nucleus in fixed energy levels. This explained atomic spectra and offered predictive power. Yet the model had limits. Electrons did not behave like planets. They did not follow classical paths. Something deeper was happening. Part 4. The quantum turn. Classical physics failed at atomic scales. Energy appeared in discrete packets. Particles behaved like waves. Observation altered outcomes. This led to quantum mechanics, a framework that replaced certainty with probability. According to quantum theory, electrons do not orbit the nucleus. They exist as probability distributions. The atom became a cloud of potential outcomes. Matter was no longer composed of things, but of likelihoods. Part 5. The wave function. In 1926, Erwin Schrödinger introduced an equation that described atomic behavior mathematically. The wave function did not describe where a particle is, but where it might be. Reality became statistical. This was not ignorance, it was fundamental. At the atomic level, nature does not choose until interaction occurs. Part 6. What the atom really is. Modern physics describes the atom as a dense nucleus of protons and neutrons, surrounded by electron probability fields, governed by quantum rules, not classical mechanics. Atoms are stable not because of structure alone, but because of balance between forces. Matter exists because uncertainty allows it to. This was a profound shift. Part 7. Consequences for human thought. The new atomic theory changed more than physics. It challenged determinism. It redefined causality. It altered how certainty itself was understood. Reality was no longer a machine, it was a process. Knowledge became conditional. Part 8. What remains unexplained. Despite success, modern atomic theory is incomplete. We still do not fully understand why quantum probabilities exist, how measurement selects outcomes, how gravity fits into the quantum framework. The atom is understood operationally but not philosophically complete. The deeper explanation remains open. Matter reimagined. Atoms were once imagined as solid foundations of reality. Today, they are dynamic systems of probability and interaction. Matter is not what it seems. It is what emerges. If this exploration deepened your understanding of the physical world, consider liking this video and subscribing to Interesting MindHub for future documentaries. Because the smallest discoveries often reshape the largest ideas.